All right, I think we'll get started. Come on in. Good morning, everybody. Thank you for making it to this session. We have probably, I think, just because of what I do, which is I'm a senior partner at McKinsey. I lead our global energy and materials practice. I focus a lot on energy transition. For me, this is the biggest question. So I'm very biased here. But it's a very critical question, which is around sustainable power generation. And of course, the topic is quite broad, right? Power generation can cover many different things. But what we'd really like to try to do is talk about systemically upstream and downstream. What do we, when we say sustainable power generation, what does that mean? And there's some very controversial issues around this. For example, the role of gas, methane in the system, when we think about energy resilience. How do we actually electrify everything downstream? So we're going to cover a lot of that. What I'll do is speak for a couple of minutes, just kind of set up the problem statement, then introduce our panelists. We've got an incredible set of panelists that cover everything from upstream to downstream, and particularly looking at transport and transport sector, which is important. And then we'll get into a couple of questions. Then I would really like to open it up to the audience and make it a bit more interactive. So in terms of the setup, if you think about power generation is at the front end of our entire economy. When we think about net zero for 2050, we have to start with power generation, because cleaning up the power stack then affects everything else downstream: industry, buildings, transport. You have land and agriculture, which is slightly separate, but the vast majority of emissions reductions will start with power generation. So the power generation sector, it's so interesting when people say net zero, are utilities and renewables developers thinking about it? Well, the existential issue in the power sector for the last 10 years has been net zero. How do we transform the business model from fossil to low carbon or zero carbon based generation? So power generation is the gateway. And just to give you some stats, we are sitting right now at 40 gigatons of carbon emissions right now, globally. If we're getting to net zero by 2050, it's about 40 gigatons that we have to figure out how do we reduce and mitigate. And by the way, if it's 2050, this decade is the decade, because the investments we make now have a 20-year, 30-year payback and affect the 2050 time horizon. But there are incredible challenges in front of us in terms of sustainable power generation too. So if you think about just the Ukraine-Russia crisis, what that's done to the fossil budget and the increase of fossil use, it's needed for system security resiliency. If you think about supply chain, interest rates, inflation, the decisions then companies have to make on investments between renewables versus fossil technologies. You think about locating renewables. A lot of the conversation ends up being about renewables. You think about land use, permitting, interconnection. This is globally. That's an issue. You think about north-south issues. In some cases, is this just an OECD perspective, a north perspective, that we should bring renewables to everything and clean up the power system? But when you go to China, you go to India, you go to Indonesia, there are people, in Indonesia, for example, electrification still has a ways to go, and coal is the cheapest source. So we get into very tricky conversations around that, and I mentioned the role of gas as well. So I'd like to talk a little bit about what is that clean stack, what is that clean stack in the future from a power generation perspective? Is it affordable? Is it reliable? Not just clean. How do we get that balance right? And what's the role between centralized generation and distributed generation? Because the next point I want to make is, as we talk about upstream, let's talk about downstream. Ultimately, the role of power generation into transport is critical. Of the 40 gigatons I was describing, about 8 gigatons is power, 8 or 10, depending on how you look at it, and about 7 to 10 is transport. So the role of linking power generation, cleaning power generation, provide clean electricity for transport is critical. With that, we get to 20 gigatons, half of what we need to do. That's big. So what is the role of transport? There's a lot of innovation happening in transport. There's a question, is it purely electric? Is it a combination of low carbon, synthetic natural gas, or CNG with electric? What is that sweet spot? Does it depend on in road transport, does it depend on the type of fleets we're talking about? Long haul, passenger. What happens to marine and aviation with synthetic fuels? which are very expensive right now. So what is that optimal mix? So we'd like to then get into the downstream transport side of things as well. So enough said, that's the setup. For this, we have an incredible panel, and I will get the names absolutely pronounced right. So we have Ricardo Falú from AES, SVP, Chief Strategy Officer, Chief Customer Officer. We have Balaji Krishnamurthy from Chevron, VP of Strategy and Sustainability. We have Levin, CEO of Scania. And then we have Thomas Healy, founder and CEO of Hyliion, hybrid lithium ion. That's what it is. So what I'll do is just a very quick minute just for each of you, and we'll go in order, just talk about what your company does. Not everybody may be familiar. In just 1 minute, we won't keep it long, and then we'll get into Q&A. So we'll start with you, Ricardo.
Thank you so much. Good morning, everyone. Thanks for the invitation, and a great pleasure to be here with you all. So AES is a global energy company. I like to say that we are a values-driven organization with a clear purpose, which is to accelerate the future of energy together. And when we say together, it's because this is an all-together effort to combat climate change. Clearly, climate change is the single most important challenge of our times, and we as a company are definitely committed to work all together to succeed in building this sustainable energy future. I would just say that we are very focused on 3 key elements or stages throughout the energy transition. One is energy security, which is the access to affordable and uninterrupted energy. If we needed a year to test this concept, 2022 and so far 2023, are proving the importance of the energy security. Second is how we continue all our efforts to build out more renewable, battery storage, and we deploy other clean technologies to basically clean up the electricity grid, which is the power sector, and then how companies such as AES go beyond the power sector to start helping hard to decarbonize sectors go green. And we have there, our solution, which is everything. And I want just to point out there that we made an announcement a couple of weeks ago with our partner Air Products for the first mega project, green hydrogen project in the US in Texas. This is a $4 billion investment to produce 200 metric tons per day of green hydrogen to green the transportation. So this is an example of AES going beyond the power sector to help achieving the common goal, which is a future 100% carbon-free system. I would just say that I would like to end by saying that we all need to embrace our ability to do big things, not only as individuals or as AES, but humankind, if we really want to succeed in what's the most challenging, I would say, job that we have, which is to build up this carbon-free energy future. So with that, I'll pass it over. Thank you.
Well, thank you, Ricardo. Congratulations on the announcement. So Balaji Krishnamurthy, work for Chevron. I lead our strategy and sustainability organization. So Chevron is a global integrated energy major. Similar to how Ricardo described his company's purpose, we believe in investing in energy to advance human progress. We believe energy is really vital to modern society, economic progress, and future of energy is lower carbon. So we are leveraging our strengths to safely deliver lower carbon energy to this growing world. That's our strategy at the end of the day. To that effect, we are investing in conventional energy while lowering carbon intensity from those energy sources and growing new energy business lines. We are committed to spending about $10 billion between now and 2028 in trying to scale and grow some of the business lines that we can get into later in the presentation or in the discussion. I would say that maybe the one last thing before I hand it over to Christian is, I think Humayun sort of foreshadowed this in his opening comments. We believe energy system needs to optimize for affordability, reliability, and being ever cleaner. If we over-index on any one of those things, I think we could have unintended consequences. So we're always trying to think about, how do we balance this three-pronged objective so that we can have a energy system that powers progress, that ensures that we have reliable and secure supply for economic growth while lowering carbon intensity. Christian.
Great, thank you very much. So Scania decided back in 2015 to make it our very purpose to drive the shift towards sustainable transport systems, meaning that we realized it was not just us, it was about the whole industry. We're largely part of the problem with 5.2% of the world's CO2 emissions coming from heavy commercial vehicles, mainly trucks. With that, then we went into science-based targets. So we were by far the first in our industry to apply and also to be approved for science-based targets. And today that is basically influencing everything we do. All our strategic roadmap is based on us achieving our science-based targets. So what we've done, we have developed ethanol solution, biodiesel solution, HVO solutions, moving into gas, moving into CNG, CBG, LNG, LBG, and then into hybridization, embracing the opportunities within electric. And of course, lately then into full battery electric heavy commercial vehicles. And we can talk more about that. And we're also cheating a little bit with fuel cells and hydrogen. So the future is clearly battery electric, whether it's about fuel cells or batteries that we can debate. But an absolute prerequisite for all of this to make sense is, of course, that we have availability of green electricity or green alternatives. And therefore, I'm so excited to be part of this panel because we need to work together throughout these value chains, or else all our efforts will clearly be in vain. So I stop there. I know there are many good discussions around it, but great being here. Thanks. Sorry, hand over to you, Thomas.
Terrific. So my name is Thomas Healy, founder and CEO of Hyliion. So while Christian is making the trucks, Hyliion focuses on producing the electric powertrains that go in commercial vehicles. And so as Christian mentioned, we're at a point today where I think everyone agrees we're going to electric, right? Trucks are going to be electrified. The reality is, though, it is an extremely difficult sector to electrify. These trucks go hundreds and hundreds of kilometers a day. They carry tremendous amounts of weight in the vehicle. And those two things are the crux of electric vehicles, right? And so this is a difficult sector to go after. So our belief is, you're going to have two different types of solutions. You're going to have plug-in and range extender vehicles. Hyliion is focused on range extender powertrains. And our goal, our mission, is that we're going to be able to produce electricity on the vehicle just as efficiently as a power plant can produce electricity. And so once you get to that point, you can avoid a lot of these weight issues, these cost issues, the infrastructure issues by just producing that power on board the truck and using that to drive down the road. So making it innovative yet practical and easy for fleets to adopt is our mission.
Fantastic. No, thank you for the intros. Just one thing that struck me is for AES, for Chevron, and for Scania, a lot of what you guys described also is a portfolio of investments you're making for a transition, because we don't know exactly what pathway, what will end up winning. And Thomas, you already made a bet because you've got an end product and a train, and you're waiting for that ecosystem to develop. So we'll talk a little bit about portfolio and ecosystem as well and the role of that. But let's start then with the first question, Ricardo, for you, which is really getting your perspective on what do you think is the ideal power system? What does that stack look like? What's the role of fossil? Is there a role for fossil? What's the role of gas? Should it be all renewables based? And how do you get resilience if you have that kind of a system? Let's talk about it from a centralized perspective, and then I'd love to also have you comment on distributed versus centralized power generation. What do you see there?
Excellent. So let me tell you, we clearly see a carbon-free energy system. So, that's our vision. We are working toward that goal. We have, phased out 12 gigawatt of coal in the last 5 years. We are committed to fully phase out coal by the end of 2025. And now, in terms of how we see the system evolving, I like what it was said with respect to this is how you balance between reliability, affordability, and sustainability. If you focus on only one of them, which eventually has been the case over the last couple of years, where you say this is only about going green and this is only about making it affordable, but you do not consider the reliability concept, then you have a problem, because you cannot run if you cannot walk. So the importance there, I think, is that we need to distinguish in the power sector two things. One is capacity, and the other thing is energy. So wind, solar, which definitely are technologies that we are deploying very, very fast, and to your point about how we see the optimal power system, clearly we see a lot of more solar, more wind, but this brings energy, not capacity. And the difference is that you don't have solar the entire day, you don't have the wind blowing the entire day. So capacity is the ability to generate electricity 24 hours, 365 days a year. For that, today, you rely on thermal generation. So gas, in our view, will continue to play a role as a transition fuel until after we can find for zero carbon emission capacity. And what we are doing as AES to change that capacity from fossil fuel to carbon-free, we are deploying batteries. Clearly that's adding capacity to the system. What we're doing there, for instance, we are combining batteries with solar or with hydro generation. You storage the energy, so when the solar is shining, you charge the battery, and then you move that electricity to the night, and therefore you are, allowing for more competitive electricity, but also reliability into the grid. But then we are also looking for other technologies that could allow us to replace the capacity. One example is the molten salt. We have one coal plant in Chile that we're trying to convert to molten salt, which is a big battery. We are also exploring small modular reactors as a way to convert or use the steam turbine from the coal plant, with the small modular reactors. And in the future, no doubts that we see green hydrogen and eventually future conversions, or use green ammonia, for instance, in some of our gas plants, in order to get to that zero energy or zero carbon energy future.
Ricardo, sorry, just one, and as you talk about that, maybe give us your view on the time frame. So when will that happen? How long will gas be in the system? What do you guys plan as you look forward?
Excellent. I think, in most of the countries where we operate, and again, we are fully committed to retire or phase out coal from our portfolio by 2025, but in many countries where we operate, the system is not yet prepared or equipped to phase out the coal. So one of the things that we are exploring is, even though this will happen, in our view, throughout this decade, where we will be able to fully phase out coal, this might vary in each of the market. So the question here is how you manage that transition using these coal facilities as big batteries, but you try to have more penetration of renewable, reducing the dispatch of the coal, and therefore reducing the CO2 emissions, but you may need to rely on these coal facilities. So in our view, coal during this decade will continue to play a role in many markets. In our portfolio, again, we are going to phase out that in full by the end of 2025. Gas, I think it's a longer time horizon. We see this more like 2035, 2040. Our commitment is to reach full zero CO2 emissions by 2040, and therefore we see that in that time frame of 2035, 2040, we will be able to convert some of our gas facilities into, eventually this green ammonia or derivatives of green hydrogen. But again, I think AES is very well recognized for innovation, batteries, but also, a small modular reactor, molten salt. So we're exploring on all these technologies that will allow us to accelerate. That's why our purpose is to accelerate the future of energy. What we're seeing for 2035, 2040, hopefully will happen earlier on. But that's sort of our view.
Great, thank you. And Balaji, maybe from your perspective, because you guys are looking at not just electrons, but molecules, clean electrons and molecules, a broader set solutions, and looking at industrial decarbon, hard to abate sectors as well, so broader set of applications. How do you think about that power stack question that I asked Ricardo, your view on the role of gas, timeframes, but also when you guys make your portfolio decisions on where you allocate capital, how do you balance the new things on the power gen side to clean molecules to the core business?
Great question. So maybe I'll start building with a theme that we discussed at the opening, right? So this sort of illustrates the role of gas. We talked about affordability, reliability, and ever cleaner. If you think about many geographies, gas is a very advantaged molecule. That can, to Ricardo's point, can really help displace coal and is a much cleaner, source of energy. And in fact, between 2011 and 2018, gas to actually coal to gas switching has resulted in about 500 million tons of CO2 reduction, right? So just to put this in context, that's about 200 million EVs on the road, right? Think about that for a second. So right now we are about, 14 million EVs, I think, right? Yeah. So I think, it's a pretty significant needle moving, the choice of fuel source. When we talk about EV, again, I'm sure we'll get into this a little bit further. The source of energy into your grid is very important because EVs is only the downstream part of, the decarbonization. But I think definitely if you want to get to a more holistic carbon reduction in the energy ecosystem, we really have to pay attention to what is the source of energy behind your grid. And also, maybe I want to slightly reframe the question, right? I don't think it's about whether it's fossil fuel or not, right? I think what we are after is emissions. And the reason I say that is, we also believe in technology, and we have been around for 143 years, and we have a long history of innovating in the fuel systems that we produce. In fact, I think a lot of people don't know this. Chevron existed even before automobiles existed, right? So I think, we get associated with the products that we use mostly today as an economy. But really, we are committed to innovating. One of the things that I love what Ricardo talked about is the human ingenuity, right? I also strongly believe in that. I think some people are very fatalistic when it comes to climate change and energy transition, but I'm an optimist. I do think we can rise up to the challenge as a human race, as a company, as a business ecosystem, as governments to solve this problem. But I think we need collective action. So just going back to the question about clean stack, so I think from a affordability perspective, like I said, certain geographies have that advantage with the gas molecules being really cheap. We have also figured out a way to transport it in a liquefied LNG or liquefied natural gas. Now with what's happening with Russia, Ukraine, it has really thrown the markets off quite a bit. But we do think in the longer run, gas is a very important part. And as Ricardo mentioned, right, in places like China, India, Indonesia, where coal is still a significant part, we do believe natural gas has a very significant role to play in lowering carbon in the overall energy system. And we talked about reliability, right? And Ricardo, I think, has a lot more experience in this than I do. And with renewable systems, you do have the challenge of grid scale storage. And frankly speaking, natural gas is as much of a complement rather than a competition to support a reliable power system. And lastly, I think we talked about the advantages of reducing emissions by switching from coal to gas. I would also say in future, as Chevron, we are significantly looking into making investments in carbon capture. And this is why my point about it's not about getting off of fossil fuels, it's more about getting off of emissions, right? So we can get to deep decarbonization by using carbon capture in natural gas and as a power generation, right? Now, I'm glad that we are trying different approaches, even on this panel, because world needs diversity of solutions, right? I think the energy system is so massive. I'll just leave with one last nugget. Today, fossil fuels accounts for about 80% of the energy system, right? Overall energy system. 20 years ago, it was also 80%, right? I say this not because we as a, as a human race, we have, it's not like we have remained stale, right? We have invested significant amount of capital, mobilized capital in building renewable energy capacity, but it's just that the system is so massive and the energy demand is growing with population that the mix hasn't really changed. So if you really want to make a difference in emissions, I do think you need all of the above. We need more energy, we need all forms of energy, but end of the day, we need to get after the emissions.
So if I can add one thing to
Go
that.
ahead.
So I agree with your statement of, if you look back 50 years, you've seen a very small shift of where the energy is coming from. And just using grid numbers, like the thing we have seen change though is 50 years ago, about 15% of the power produced was coming from petroleum. Now we're at about 1% of the power plants are using petroleum. So now the next shift is we need to move off of coal, right? So I love what AES is doing, but I question how much more renewable we're really going to be able to add quickly. I think the next mission here is let's move off of coal. Let's move into more fuels like natural gas that are a lot cleaner. But I agree with you of like, we haven't seen a massive shift. It's still 80% is coming from petroleum-based or from fossil fuel-based solutions.
Well, one of the biggest levers of decarbonization has been the reduction of coal power generation overall, so that's been good. But maybe taking, Christian, I wanted to ask you, because you talked about SBTi commitments you've made, but we are just hearing about the end state of the grid, which is even for the next 30 years. I get the point on net zero, so it's about emissions, so you can do CCUS, carbon to offset what will be an emitting grid still. But when you look at that makeup of the grid and your commitments to SBTi, look at scope 2, do you say 20 years from now, if there's gas in the grid, there's some coal generation, that you are actually delivering on your commitment to have zero carbon electricity for your infrastructure, for your automotive products?
Yes. Yes. Does it work? Can you hear me? Okay, good. No, but just to add to the previous discussion, I mean, we need to be much more aggressive in going fossil-free. I mean, that's the whole point of this exercise. When we look into our own manufacturing system, and we're a pretty heavy industry, we are already 97% fossil-free. So we do find alternatives. We do find green biogas to run our factories in Brazil, for instance. In Europe, we're happy to be in the northern parts. I mean, it's of course easy to find non-fossil energy. So to live up to the scope 1 and 2 commitment in SBT is not the big challenge. It sounds cocky to say so, but that is not the big challenge. The big challenge is on scope 3. And there we now started with the supply chain, and we are having a very good success in getting the suppliers on board, including the difficult ones, such as steel, aluminum, cast iron. And we have set up to 2035 that needs to be completely decarbonized. And the suppliers are with us on this. And there are new suppliers, as you know, who challenge the old ones, but also the incumbents start to move in this direction. And with that time frame, they say it's possible. What remains is the use phase, vehicles in use, which is what we are fighting for, to get then customers to transition. And of course, and then there are 3 big hurdles. And the first is, of course, the business case. It's still cheaper to go for fossil diesel, and therefore you have good business there. But of course, that needs to be offset with some kind of price on coal or price on carbon dioxide, which has been tested in several industries. It works. And I was super happy when the ETS came into the Fit for 55 in Europe. Let's see now how the implementation goes, but that's the perfect instrument to make it financially viable for our customers to shift away from fossil diesel into whatever that is non-fossil, right? I think that's one super important part of it. And then when we come to full electrification, which is the ultimate goal, and it will happen, I mean, we say 50% of our sales already in 2030. I know that's quite aggressive. If that is achieved by us and our peers, that will need 60 terawatt hours of additional energy. So not only does the grid need to be decarbonized, it also needs to be expanded with much more capacity. We know that's a huge challenge. So I'm not saying, you guys are not having an easy job, but some way we really need to solve that, or else all the investments that we're doing in the vehicle sector, and it's not only Scania. This is happening in Volvo. This is slowly happening at Daimler. It's happening with all the peers in the US, because it's simply the way we need to go. But I think that is to decarbonize that is the other challenge for our customers. That's a question where you see if the business case is okay, and it will be through incentives. Where can I charge, and is the electricity going to be green? You know, these are the two other questions that are coming up, and I think my answer so far is, well, I have a commitment from the energy suppliers. By 2030, you're going to be the grid is not going to be 100% clean or green, but there's going to be contracts available for you. And by the way, we supply them for you. So we bundle them in a Scania and we sell them together with the vehicle.
So Christian, on that, let's say you're in a geography, you're selling your products, your trucks, and you've got in the power stack by 2030 still 10% coal, 20% gas. In that case, I think if I interpret what you just said, then you are bringing in contracts, virtual power plant contracts on renewables to decarbonize.
And that's possible already today in many geographies.
Yeah.
And of course, I'm not naive. I know, for instance, in big parts of Latin America, where we are a really big player together with our sister company, Volkswagen. There, of course, we need to go for instance, biogas, which is renewable. You know, so I think that's the other way to solve it. But yes, you can find contracts where there is then 10 or 20 or 30% remaining fossil. That will be enough to live up to our science-based targets.
But then what does that do to the affordability of the product? Does that increase the cost? Or do you find the right customer mix? How do you think about that?
It does increase the cost. It does increase the cost, and in some parts significantly. And of course, that's where the legislator will have to help. But what I hear from Biden administration, what I heard yesterday from Ursula von der Leyen, is very good news. They are prepared to step up and at least short term try to bridge this inequality, give incentives so that we can scale, so that me and Thomas can get some volume and through industrialization bring down cost and then offset these additional costs that the energy will be. But I think we will have to live with that cost for quite a long time.
Yeah. Yeah, so if I very helpful. So if I synthesize so far, we're talking about upstream power sector, even by 2040, 2050, I would say there's going to be some element of fossil for resiliency, affordability. The way you make the transport sector work is then you do off-takes for specific contracts to clean out that, to make the commitments happen. It may be more cost, so you need then the incentives. Either it's a carbon price, in some regimes it's a direct subsidy from other governments to make that happen.
Exactly.
But at the end of the day, then back to your point on infrastructure, which Thomas, I'd love to get your view on. How do you make that last mile? It's not even last mile, right? It's the utilities, the T&D, transmission distribution infrastructure, the EVCI charging infrastructure. How does that work, that ecosystem? There's this whole chicken and egg proverbial thing of you can't get enough charging infrastructure because you don't have volume, but vice versa. So is that broken? What do you see? What are the challenges there?
So I think it's actually very broken. And just to put some examples to this, we're chatting with fleets in the U.S. all the time, and a lot of them are looking at adopting BEV plug-in vehicles. The problems they're running into is they're going to their utility provider and saying, I want this much power to charge my vehicle. And they're getting told, great, you can put 3 chargers in, you can put 5 chargers in, right? That's it. You don't have enough power to go more than that. So, and actually, I shouldn't say chargers, I should say vehicles. Actually, there's a story that one fleet shared with us. They said they went to their utility, they needed the power for 5 vehicles. The fleet told us the utility literally laughed at them and said, no way you're getting that much power. And so then they went back to the provider of the vehicle, and the provider said, well, why don't you build a warehouse? We'll put a bunch of batteries in this warehouse. Then when your vehicles come in, your vehicle will charge off of the warehouse, and the warehouse will be constantly getting trickle charged by the grid. Oh, but by the way, you can only drive your trucks 4 out of the 7 days of the week because the other 3 days the warehouse needs to get recharged. That's for 5 trucks, right? That's not even putting a dent into the problem we have in the commercial vehicle space. So I strongly believe we've got a massive issue of how are we going to provide enough electricity to charge these vehicles, and that's where our whole company is focused on, well, let's actually make range extender vehicles. You don't need to use the grid to recharge these vehicles. You produce the electricity locally. And you mentioned Latin America being a great source of biogas. I actually believe the U.S. and many other locations, biogas is going to be a dominant source. One stat in the U.S. is 63% of the fuel that was sold at natural gas stations last year already came from biogas or renewable natural gas sources. So now over half of the fuel, that's being sold is already renewable, and this fuel has the ability to be net carbon negative. It's fantastic. So we got to eliminate this misconception of a BEV plug-in truck is the only zero emission solution. Well, the reality is it's not zero emission. If you're in Kentucky and you plug in and there's, you recharge your vehicle, 70% of that electricity you just got came from a coal-fired power plant. So let's remove the misconception of BEVs are zero emission. Yes, they're zero emission at the tailpipe, but they're not zero emission overall.
Yeah.
Can I just build
Please,
on that? I think, Thomas, you just hit a very important point. I do think overall as an energy system, we need to be paying attention to the life cycle, right? I think I love what you said, right? There is no such thing as really zero carbon because, even if you're doing, wind, and in fact, Ricardo, I'll be interested in your comments on whether you guys have systems to understand it. Whether it's solar to production of panels all the way to critical minerals to in power generation, everything has certain carbon intensity associated with it, right? End of the day, our goal is to reduce that life cycle emissions, not just a box that we draw around one part of the value chain, which is a very important concept because you can end up with different solutions and still not get to our end goal of net zero. Thank you for making that.
Well, let me add to that, in AES we've been very focused on decarbonizing the mining sector, for instance, of Chile. So if you decarbonize the copper, and then you also, through green hydrogen, for instance, green ammonia, you can use it as a carrier for the shipment. So these are ways in which you are helping these hard to decarbonize sectors go green, so that by the time you really charge your EV, you can really say, yeah, this is, low carbon emission at least. In the US, we own some distribution companies, and we also own a company called Motor. Motor is an EV, I would say, or a company to encourage or foster, the adoption of EV in the US. So we own the distribution company, which in my view, it's an enabler for to electrify everything. And then we have this Motor. So what we are doing now is partnering between the two so that we can, of course, encourage people to adopt the EV, but at the same time, make sure that we have smart solutions to the grid to be able to support, this increase of electrification, which is the ultimate goal that we have. And I just want to link this with my previous comment, which is AES is about energy security for the power sector, cleaning up the electric grid, which is reducing the CO2 emission of how you produce electricity, and then electrify everything. So this is in parallel. It's not, these are not separate. This has to be done in parallel. So hopefully in the future we will be able to say, yes, we have a power sector that is fully green, that we can electrify other sectors, and also that the value chains, the complete value chains of the critical minerals, were also decarbonized. So this, just to give an example of how we are approaching this very important, problem that was raised.
If I can just add to, Chile is a great example where we sell both very many buses and trucks fully electrified. And of course, we can't wait until the grid is fully decarbonized. Why should we? Correct. We cannot make the perfect the enemy of the good. So we need to move, because there's so many other, now we talk about two big blockages. There are so many other difficulties in this transition. The vehicle is much more expensive, needs much more financing. So it's a different business model that is being developed. The grid capacity that you were into, we haven't touched that much. So there are loads of other problems. They will only be solved ultimately when people start, when our customers actually start to use electric vehicles. So it's super important that we get going. And then whether the mix is 70, 60, 40, 50, it doesn't really matter today. And we try to offset that with contracts. But of course, Thomas is ultimately right. It's still dirt in there. Yeah. And the tailpipe is not a good way to measure sustainability. It has to be done well to wheel. But we need to get going. And I think there's a lot of momentum being built up now. And I just love what Chile is doing, because that's such a great example. And then you move over to the other side, and move over to Brazil, and you think, oh my God, electrification is never going to happen. But it's happening inside cities. And for sort of distribution vehicles, we see really good uptake of smaller electric vehicles. And then biogas comes for the long haulage. So there are, it's not one solution. That's very clear.
Right.
There are numerous solutions that needs to be developed in order to decarbonize.
Balaji, go
Can I
ahead.
make one point? I think so, you just said something very powerful, right? We just can't wait for the perfect. We need to get going today. On that theme, I know we didn't touch a lot on renewable fuels. Again, we all know vehicle stocks take time actually to turn over, and then the electric vehicle, infrastructure to catch up, even though that's, we believe that's the direction the world is headed. But the renewable fuels pathway provide lower carbon intensity on a life cycle basis today, right? So I think that's another area that we are leaning into, is making sure, not wait for necessarily, the perfect pathway, the perfect grid, the perfect electric vehicle infrastructure and charging system to show up. So we can actually make a difference today, which I think makes a significant impact on the carbon emissions.
Yeah, it just strikes me, to make these pieces work, the amount of policy support, in the absence of a carbon price, of course, if you had a carbon price, lots of things would fall into place, and the supporting infrastructure on things like transport. In the absence of that, the patchwork of incentives and subsidies that need to happen, otherwise bets are not made. And I do think actually the carbon footprint of a wind turbine, a carbon footprint of an EV, it is much improved life cycle. I don't think the awareness is there. I think oftentimes I find that people still have the view of 10 years ago that, first in, first out, you actually are negative carbon on, you're positive carbon emissions on a turbine. I don't think that's the case anymore. And we know it from recycled materials, all the circular economy stuff that's happening, which has been a fascinating shift. Let me turn it into the audience, and I would love to get some questions, and we'll start right here. We have a mic right back. Oh, sorry, somebody has a mic here. You've got a mic. Sure, thanks.
My name is Philippe Monnier from Switzerland. I represent different organizations. I have a question for Scania maybe. What do you think of the role of regulation? And in particular, what do you think of the decision of the European Commission to forbid ICE starting 2035?
Yeah, so that's clearly on the passenger car side and for small vans, so it's not directly affecting the sector I represent. But of course, if you take such a decision, you put, of course, an enormous amount of pressure on the industry. But I think you put equal amount of pressure on yourself as a legislator, because then it's your responsibility to make sure that the preconditions are in place to make that transition. Today, they're not in place. There is no way that, we see a good uptake on electric cars, and that's very promising. But to have a sustainable, stable energy supply for all these cars, there are loads of investment that needs to be done. Many of them are state investments. So that's why we are hesitating on the commercial vehicle side, say, okay, should we have a date? Should we have 2045? It's more difficult to decarbonize. I don't think that is the way to go, to be honest.
Would you prefer that they set some numerical targets in terms of CO2 without telling the industry this is a technological solution you have to adopt, forget about ICE?
They should always avoid talking about the technology solution. That's where policymakers always go wrong, right? So tell us what we need to achieve in terms of CO2 reduction. But the best way to do that is to put the price on carbon. Put it at 200 and keep increasing it. And then the market will regulate itself. So I think that is what we need to do, and I think that's what Switzerland should do and show the way for Europe, as you've done in many other areas.
Thomas, you, I think, wanted to add on, then I'll go to...
Yeah, so one philosophical thing that I don't like is, let's not build solutions that only work if there's government incentives in place. Right? If we're going out and building electric vehicles that, hey, the only way fleets are going to adopt these is if the government's going to wrap a few $100,000 around the vehicle for them to adopt it, that's going to go away at some point, or at least it should go away at some point, right? And so that's where we've been really focused on, can we bring solutions to fleets that are actually going to be at cost parity or potentially even cost less than diesel solutions? The only solution that we've seen that can do that is actually by using renewable natural gas or natural gas. Nat gas is about $1 a gallon right now compared to about $4 to $5 diesel fuel. Electric grid is about the same cost as diesel fuel today, and then hydrogen, it's about double the cost of diesel. So that's where I think incentives are good to get started, but we can't be looking at incentives as we're going to need them forever.
And I'm fully with you, but you need that in order to get the scale going. And of course, natural gas is fully fossil, so it doesn't really solve any problem. more than short term.
Well, the other thing I'd add is, I mean, realistically, subsidies have been around for more than 50 years, right? If you look at ITC and PTC credits for renewables, it continues. So I can't actually see a system where you don't have the incentives in the absence of a carbon price. It's going to happen. It's going to continue from my view. Let's go. I think there was one here, and then we'll go back there.
Hello. My question is in particular for Chevron. With the CCS now, I think post COP27, a lot of companies, even obviously big difference from COP26, showed up and spoke a lot about CCS as a short-term solution. I think a lot of criticism, obviously there is a part which is that is lingering the long-term solutions and it's probably going to slow, but there is a low-hanging fruit there that brings. The bridge is most of the companies are not talking about where is the technical limit. Where is that? How much CCS? First of all, the cost, the technology evolution, because everybody assumes that we're going to repurpose the existing setup and to use it, but also what is the technical limit? At which point we say that's maximum CCS could achieve, and then the rest should be achieved through 1, 2, or maybe it's a time zone. I think for big EMP companies, that's my point, should come up with that more speech. Otherwise, CCS will always be looked at in a very negative way, cornered as a lingering tactic rather than a true short-term solution.
That's a great question. I think I want to build upon what Thomas said, right? I think the CCS as a technology, I mean, as you probably know, I think it's feasible, right? We have done this, the industry has done it for decades and decades, right? I think in many cases it was used to enhance oil recovery, but we have also had many examples where we have injected CO2 just for storage. And by the way, these are high quality, right? You can actually prove a molecule of CO2 that you put in the ground actually remains in the ground. So I think it's not a question of, in my mind, it's not a question of technical feasibility. We can prove, we can do it. I think the reason I said I want to build upon what Thomas said is this is a classic case of you need policy enablement to build a scale, right? You don't want to depend on it forever, but I do think one of the key barriers to CCS is, depending on the cost estimates that you believe, is somewhere between $200 to $400 per ton. But even in WEF, I met some of the companies that are pioneers in the CCS space and carbon capture space, and they have line of sight into getting that cost down significantly, right? Let's say $50, $60, which are below some of the IRA incentives for carbon capture. So I completely agree with your premise that as an industry, as an energy ecosystem, we can't be talking about CCS as a nice to have down in the future. We actually can move, but we are seeing momentum build on CCS, particularly with the IRA in place in the US. I think we are going to see a lot of momentum in scalable, large-scale projects to put away significant amount of CO2, which I think is very essential in our journey to get to net zero.
Just to add, it's a really important, I'm glad you raised the CCUS point. If you think back to the 40 gigatons I was describing, large segment of that, about 15 gigatons, or 12 to 15 is industry, hard to abate sector, that's the largest sector. We cannot foresee a solution getting to 2050 without CCUS being part of the solution. And what's happened so far is carbon removal has been treated kind of negatively, right? It's like kind of on the side, it's niche-y. But the speed and volume of which $150, $165 IRA type credit or $185 for DAC per ton provides is to get that volume and speed there. So that's got to have, it's going to need to play a role if we think about the 2050 time frame. Question over there. And please introduce yourself also.
Thanks. Hi, my name is Inam. I'm from Pakistan. I set up what is now the largest solar company in that country. Perhaps a little digression from what you guys have been talking about, but everybody has talked about capacity and storage. So, who's bothered about that? Because the only storage that I seem to hear and is echoed is fossil fuel or gas. So, but what and a little bit of hydrogen thrown in, and et cetera, et cetera. But what's really happening in capacity building, in storage, and who's bothered about it?
Well, AES is.
I know AES does something.
Okay, thank you so much for Great question. I think, we've been deploying battery storage, solutions. I think Chile is one example where we are building a very large, battery storage systems together or, combined with solar, also with run-of-river hydro, because the run-of-river just, they don't have reservoirs, so they produce the electricity once the water goes down the river, and that not necessarily is during the peak hours. So you want to charge the battery and keep that, energy or electricity stored so that you can inject it into the grid at peak hours. So we are doing that in Chile. We are doing that in Hawaii. Actually, we were able to phase out our coal plant in Hawaii by deploying solar plus storage using, these batteries. And I think the point is, clearly these are lithium batteries that we are deploying, but we are agnostic to the technology. Really, it's about how we are integrating, technology in order for us to add renewable capacity next to the renewable energy. And I think, green hydrogen, fuel cells, all of these are ways that if in the future place to be more cost efficient, for instance, as we electrify the mining companies' track, perfect. We will embrace that technology and we will ahead. So I think that's the answer, to your question. I think the only other element that I wanted to comment with respect to policy is critical. But what we are seeing as AES now, as our major challenge to accelerate decarbonization, is that we're facing a decade-long shortage of all the inputs that are required to make our customers green. So let me give you an example. With the Inflation Reduction Act, clearly, we have a humongous demand for renewable. Our customers, this is not like in 5 years ago that we needed to convince our customer, embrace renewable, let's go green. No, now the demand is humongous, but the scarcity has shifted to the supply side of the equation. And we don't have enough land, we don't have enough interconnection, we don't have enough turbines, we don't have enough panels. So I think also in terms of policy and governments, this is about how we build reliable and integrated supply chain. Even copper, the current volume is not enough for what we need to get to the net zero goal that we have. So I just wanted to raise that other point, because policy in terms of pricing the carbon emissions, and that's very important to get to the scale that will allow your industry to be competitive without the subsidies. But then is how you fix the supply chain problem. It's also something that we will need to work all together.
Great. Thomas, you...
So I think batteries are going to help with peak shaving, right? Which is going to be a big benefit to the grid. But I think we ultimately just need more power generation for the grid as well. And so there's two different philosophies. One is you have the big power plant that goes out and distributes power to everything, or you have more of a distributed grid setup where you have mini power plants all around that are feeding electricity into the grid. We're actually, a second part of our business is focusing on the latter there, where we've got a generator solution that has efficiencies that rival the same efficiencies of the best power plants out there, but yet it's also fuel agnostic, and it can fit in the size of basically the trunk of a car. So if you could actually have mini power plants all around producing electricity, they can use various different fuel sources, hydrogen, nat gas, even ammonia to go into that generator to produce electricity. I think that is another element we need to support the grid, in addition to having battery capacity to reduce peak.
And I want to add to that the small modular reactor, that I think it's another technology that we are exploring, and it's, it sounds promising. And second, the molten salt, which is really the way we expect to convert some of our coal assets by, heating the salt. You use that salt, you have the steam generator, and then you use all the infrastructure of the coal plant to produce electricity as well. So I think in terms of the capacity, fully agree. I think that's the main issue that we have to resolve in the power sector, to have this carbon-free or low carbon if you were to use gas.
But one quick question, Christian, on this point on storage, vehicle to grid. So if you think about the fleet of Scania trucks that are across, is that a possibility? Is that happening? What do you see there?
It's not yet happening, but there are lots of discussion about it. Of course, a lot of vehicles are not utilized 24/7, especially the big bus fleets that are the first one to electrify now are standing still at night. They're standing still at midday, which is even more interesting, of course. And if they all carry 300, 400 kilowatt hour of energy storage, and you take an average bus fleet in Europe being 200-300 units, you have quite a lot of energy there. Yep. So the trick is now on the digitalization side to find a way, to master this, who sold what to whom.
Right.
And of course that's not a small challenge.
Right.
But I'm sure it's something that is coming, and maybe even more so on pass cars, because they stand on average 97% of the hours of the day, right? Just standing still. If they could be connected and the battery is fully charged, I think that's something that you could draw on as an owner of the grid, should draw on as an owner of the grid, yes.
For second, minute, and hourly stabilization. Thomas, you're going to add one thing?
So your thought is commercial vehicles, like over-the-road commercial vehicles, probably not so much vehicle back to grid, but pass car is going to be more
certain applications. But I was surprised when I looked we have 600,000 connected vehicles. I was surprised looking into, on average, how little they are utilized. And that's probably down to the shortage of drivers. But the average in the Scania fleet around the world is 9 hours out of 24. I would have expected that to be much, much higher. So there isn't, let's see, now when the asset is 3 times more expensive because batteries being very expensive, that hopefully changes. But there is still some, and we need to prepare technically the vehicles to give the energy back to the grid. There's no doubt about that.
I know we're at time, and we didn't get into things like supply chain for all components. I mean, even in storage, think about long duration versus 4 to 6 hour lithium. You look at nickel, NMC type. There's all sorts of issues. The geopolitics of where the supplies come from. Look at what's happening in South America versus China, refining capacity. So I wish we could have a couple more hours on that. Just that topic is fascinating. But thank you so much. It's hopefully, the problem with these panels on topics like this, they're so broad that how does it become relevant to you and the audience for the specific things you're coming from, right? Which is CCUS or storage. So, and then for you guys, which is you're across the spectrum. So hopefully we got to some specific things. Obviously, point was not to solve anything, but point was to really bring to life the upstream and the downstream pieces. But thank you so much. Fascinating conversation and really interesting insights and specifically what you guys are doing and how you're thinking about it.